So in this video, we're going to go over adding and subtracting rational expressions. So if you remember, when we add and subtract rational expressions, it's similar to adding and subtracting fractions. So they must have a common denominator, then we're going to just add and subtract the numerator. So for example, when we have 2 over 5 plus 7 over 5, we have a common denominator here, so we're just going to do 2 plus 7 over 5, and that gives us 9 over 5. Now, when we don't have a common denominator, we have to get a common denominator. So we want to look at our least common factor. So 2 times 6 is 12, right? And 2 times 4 is 8. Notice that the 2 is repeated. So we're going to look at 6 times 4. Well, 6 times 4 is 24, and that is the least common factor. So what we want to do now is figure out what do we have to do to get 24 in the denominator for this 11/12. So we are going to do 11/12 times 2 over 2, because that's going to give us 24 in the denominator, and 2 over 2 is 1, so we're not changing the function there. And then we're going to subtract from it 3 over 8, and what do we have to multiply by 8 to get 24? 3, right? So we're going to multiply that by 3 over 3. So now what we get on top is 22 over 24, right? And then minus 9 over 24, and that's going to give us 13 over 24, and that would be our answer once we have our common denominator. So notice again that when I have that 2 repeated, I don't have to use it. What I need to do is find the common denominator from the other two numbers, which would be 6 times 4. Okay, so and the way we do this when we start talking about polynomials is we're looking for the least common multiple of polynomials. So we're going to find that by factoring each polynomial, like we did here with the x to the third plus 6x plus 9x. The greatest common factor was an x, and then we get x squared plus 6x plus 9, and that factored is x plus 3 squared. Then we're going to list the different factors, and if the polynomials have common factors, we're going to use the highest power of each common factor. Okay, so on this next example, what we're going to look at is 4 is 2 times 2, and then we got the x squared and the y to the third, and then we're going to look at the 3 times 2, and we got x to the fourth and the y to the fifth. Now recall again, we're looking for the highest power, okay? So, and we're looking for all the different factors. So we've got 2 and 3, and then the 2 is repeated. So what we're going to do to get our least common multiple is we're going to multiply 3 times 2 times 2, and then we're going to take our big, the fourth, and y to the fifth, yeah. So that's going to give us 3 times 2 is 6 times 2 is 12. So it's going to be 12 x to the second, x to the fourth, y to the fifth. Okay? So on the next one, we're going to factor both of these. So we're going to factor the 2x, recalling again that we need to multiply these here, so that's going to give us 42. So I'm going to pull down my 2x. Now you can do bottoms up or you can do this. It's your call. I'm going to do 2x and 2x, and we're going to look for the factors of 42 that add up to be negative. Sorry, that's a negative 41, isn't it? So that would be minus 14 and plus 3. And we have a GCF over here of 2. So this is going to be x minus 7. And then we have 2x plus 3. We're going to do the same thing over here with the 3x squared. So this right here is negative 105. So again, we're looking for the factors of negative 105 that add up to be negative 16. So again, I'm going to do my 3x and my 3x. And again, you could use bottoms up here as well. It's your call. And so if we look at the factors of negative 105 that add up to be negative 16, they end up being plus 5 and minus 21. So here again, I see a GCF of 3. So this is going to be 3x plus 5. And this is going to be my x minus 7 again. So we don't have to write the repeated factor twice. We only have to write it once. So again, to find our least common multiple, we're going to have our x minus 7. Then we're going to have our 2x plus 3. And then our 3x plus 5. And those three would be our least common multiple for that pair of polynomials, okay? So now I'd like you guys to try the third one and then come back to me when you're done. So the factors of this one, what are the factors of -3 that add up to be -2? That would be x minus 3 and x plus 1. And then what are the factors of -6 that add up to be -1? So that would be x minus 3 again and x plus 2. So again, notice that we have this repeated factor. So we don't only have to write it once. So we're going to write x, sorry, right here, x minus 3. And then our x plus 1 and our x plus 2. So that would be, again, be our least common multiple, okay? Now this can become relevant in just a minute when we start adding and subtracting. So here it says add or subtract and identify any x values for which the expression is undefined. If you remember what that means we set whatever the factors of the denominator are equal to 0. So on this one, notice that they already have a common denominator. So on this one, all we have to do is add the exponent. So we got 4x plus 5, and all of that would be over 12x, wouldn't it? Okay. So recall again that we have to set our denominator equal to 0. So we're going to do 12x equals 0. Divide both sides by 12. So x cannot equal 0 because 0 divided by 12 is 0. So now we're going to do our U-try. Pause the video, go ahead and do this, and come back to me when you're done. So here again, we got our x plus our y plus our x plus our 3y because they're both over the same 12y, right? So we're going to look at our like terms. So we got an x and an x, that would be 2x. We got a y and a 3y. So this is going to be 2x plus 4y over 12y, right? Now, hopefully you can see that all of this reduces by 2. So this is going to be x plus 2y over 6y. And once again, we got to set our denominator equal to 0. This as well, divide by 12, right? So this is going to be y cannot equal 0 this time. So now what we're going to do is we still have a common denominator, but this time we have some binomials on top. So we're going to, and we have a minus sign. So we're going to do x minus 3 minus an x minus 2. Now we can multiply a -1 times all of that. And again, it's still all over x plus 4 because we still have a common denominator here. So we can do a couple things here. Again, we can either multiply all that by -1, in which case the first term would be become negative and this would become positive. Then we're looking for our like terms again. Well, if we have an x minus an x, then obviously the x's are going to go away, right? And then we have a -3 plus 2, so that's going to be -1. So this would end up being -1 over x plus 4. That would be our answer. And then remember, we got to set this x plus 4 equal to 0. So x cannot equal -4. So that's the other part of our answer. So this next one is again a U-try. So you guys go ahead and do it and then come back to me when you're done. So this one has a common denominator again. So we're just going to do our x plus 5 minus an x minus 3. So once again, we've got, this is going to end up being negative, but that's going to end up being positive. We're going to change the sign. So we got an x minus x again, and then we got the 5 plus 3. So that's going to just leave us 8, and all of this would have been over what? X plus 2. So that's going to be, sorry about that, that's going to be 8 over x plus 2. And again, we got to set that x plus 2 equal to 0. So that would be x plus 2 equals 0. So x does not equal -2. There's where, again, is where our expression is undefined. So let's go on to our next ones. So this time we don't have a common denominator. So what do we have to multiply by x to get x squared? We have to multiply that by an x, right? So here we're going to do 5x, and then we got that plus 3 times over x squared. So over here we're going to have to multiply this by x over x to get x squared in the denominator, right? So that's going to give us 5x plus 3 all over x squared. And once again, we're going to set this equal to 0. The x squared equals 0. So that would be the square root. So x cannot equal 0 here again, okay? So now go ahead and do the U try and come back to me when you're done. So on this one, again, we've got our 10x over x to the third minus 8 over x. Now, what do we have to multiply by x to get x to the third? X squared over x squared, right? So that's going to be 10x minus 8x squared all over. Now we have our common denominator, right? So that's going to be x to the third. And here again, we're going to say x to the third, set it equal to 0. We could take the third root of this, right? That would still give us a 0, right? So x cannot equal 0. So it went 2 ahead. So let me go back one. Yep, sorry, right there. Okay, so now number 10. This time we don't have anything in either denominator that's common. So what we're going to have to do is multiply both the numerator and the denominator by the opposite denominator. So I'm going to say 3x minus 2 over 2x plus 5. And I'm going to subtract from it 2 over 5x minus 2. So what I'm ultimately going to do here is I'm going to multiply this one by the 5x minus 2 over 5x minus 2. And then this one over here, we're going to multiply by the other one, 2x plus 5 over 2x plus 5. So when we do this, in the numerator, this is just going to be, you could use the box here, you can use FOIL. So I'm going to use FOIL. This is going to be 15x squared. Outside is going to be negative 10x. Inside is going to be negative 6x. And then we got plus 4. And then we're going to subtract from it the other one, right? So all of this would be over the 5x minus 2 times 2x plus 5, right? And then over here, and I'm just doing the minus like this time so you guys can see, this would be 2 times 2x. That's going to be 4x plus 10, right? But remember, we're going to subtract all that. So all of this is going to be over 5x minus 2 again times 2x plus 5, right? So now what we need to keep in mind is that we are subtracting all of this again. So we're going to change both those signs. So this is going to be a minus 4x and a minus 10, right? So here again, because these are all over the same common denominator, we're just looking at like terms. Well, notice also right here, we can combine these two terms, right? So this is negative 16x. And then we're going to have a minus 4x combined with that, right? So you guys see this right here? So that's going to be 15x squared. And then also notice that we got a plus 4 minus 10, right? Y'all see that right there? So we're going to also be able to combine those terms. So we got our negative 16x minus our 4x, so that's going to be minus 20x, right? And then we got our 4 minus 10, so that's going to be a minus 6. So all of that then is going to be over our 5x minus 2 times 2x plus 5. Now, there's something I need to bring to y'all's attention. So what we always want to do here is try to see if we can factor the numerator, right? So I did try to factor this. I tried to see, first of all, I don't see a GCF in the numerator, so I can't do that. And then when you multiply negative 6 times 15, you get negative 90. Well, I couldn't find any factors of negative 90 that added up to be negative 20. So I really couldn't simplify this any more than it is right now. So when I write the final answer of this problem, I could leave it like this, but then typically what I would do is I would also multiply the denominator. So what we're going to get is 15x squared minus 20x minus 6. And again, you can use the box or FOIL here for the denominator, and that's going to give me 10x squared. And then I've got 25x minus 4x, so that would be plus 21x minus 10, because negative 2 times 5 is negative 10. So that's our answer right there, guys. Now, the last thing we need to do is go ahead and set our factors of our denominator equal to 0. So we've got our 5x minus 2 equals 0. So we're going to add 2 to both sides. So that's going to give us 5x equals 2. Then we're going to divide both sides by 5. And so that's going to give us, let's see if I can scroll down, y'all. So this one's going to be x cannot equal 2/5. And then we need to do that with our other factor as well. So then we have our 2x plus 5 equals 0. So we're going to subtract 5 from both sides. So that's going to be 2x equals negative 5. And then we're going to divide that, both those sides, by 2. So x can also not equal negative 5 over 2. It's kind of not legible, but let me fix that a little bit, y'all. So, yeah, I don't know what's up with my pen right now, but it's kind of lagging. So this was over 2. So the answer is x cannot equal negative 5 over 2. I don't know if that's much more legible, but you guys see it. So now the last one, or the next one, I'd like you guys to go ahead and try it and then come back to me when you're done. So here again, we're going to do 7 over x minus 8 over x plus 4. And we're going to go ahead and multiply the numerator and denominator by the x plus 4 because that's the other denominator. So x plus 4 over x plus 4 here, and then over here, x minus 8 over x minus 8. So x times 4, or I'm sorry, 7 times x is 7x. 4 times 7 is 28. Then we got minus 8 times x is negative 8x, and then we got a minus 8 times a negative 8. That's going to be a plus 64. All of that's going to be over our x plus 4 and our x minus 8. So now we got some like terms here we need to deal with. So we got the 7x and the minus 8x and the 28 and the 64. So that's going to give us minus x. Where's my cheat sheet over here somewhere? I think it's 92 plus 92 over, again. Now we can go ahead and multiply out that x plus 4 times x minus 8. That would give us x squared. And that's minus 4x minus 32. Okay, that would be our answer. And recall again that we got to set these factors equal to 0. So that would be x plus 4 equals 0. So x cannot equal negative 4. And then we've got x minus 8 equals 0. So x cannot equal 8. All right, number 12. So this one's a little more complicated because we've actually got a trinomial in the denominator. So we're going to have to factor that first and see what the factors of that are. So let's go ahead and do that first. So what are the factors of negative 4 that add up to be positive 3? So that would be x plus 4 and x minus 1, right? Okay, so notice now we have one of those factors repeated in the other term that we're going to add to it. So what are we going to have to do? The x plus 4 to basically make it have the same common denominator. So I'm going to rewrite this x minus 3, and I'm going to go ahead and leave this x plus 4 times x minus 1, and then I'm going to add to it the 2x over the x plus 4, and then obviously we're going to have to multiply this by x minus 1 over x minus 1 so that we'll have that common denominator. So now we've got x minus 3 plus 2x times x is 2x squared, right? And then we've got 2x minus 1, so that's a minus 2x that we're multiplying there, okay? So now we do have a pair of like terms here, and I'm going to go ahead and put this all over the x plus 4 and the x minus 1, okay? So now notice we do have a pair of x's here, right? So we have x minus x, so we're going to get I'm going to write it in descending order, 2x squared minus x minus 3 all over x plus 4 and x minus 1. Now, what I'm always going to do when I end up with something like this is I'm going to factor the numerator, okay? So notice again, if we multiply a times c, we would get a negative 6, right? So what are the factors of negative 6? That when added together give me a negative 1. So again, remember, there's two ways we could do this. We could do the bottoms up way, and I'm going to do that this time because I haven't done it in a minute. So we've got x, and that would be minus 3, right? And x plus 2, right? And again, we will put this 2 out here, and if we can divide it, we would. And if we can't, then we would go bottoms up, right? So this is going to be 2x minus 3, because that's our bottoms up method. And this would be x plus 1, okay? Then notice in the denominator, we don't have any common factors. So just going to rewrite that in the denominator the way it was to begin with, if I can get my pen to work. So I'm going to go ahead and put this over x plus 4 and x minus 1. Well, I don't see anything repeated there. So I'm just going to go ahead and rewrite this again in the numerator because it was already done. So that's 2x squared minus x minus 3 over our, and then we can multiply this out. So notice it was up here already. So we can rewrite it like that too. X squared plus 3x minus 4. So that was our answer. Now remember, we still got to set those factors of the denominator, equal to 1. So we got our x plus 4 equals 0. So x cannot equal negative 4. And then we've got our x minus 1 equals 0. So x can also not equal 1. All right, let's see if you guys can do number 13 and come back to me when you're done. So here we go again on this one. So this factors out. What are the factors? Again, we're going to ask ourselves of 9 that add up to be 6. So that would be x plus 3 and x plus 3, right? So when we're looking at this one over here, the left one, we have to give it a common denominator. So if we've got x over x plus 3, we're going to have to multiply both the numerator and the denominator by x plus 3, right? I'm going to go ahead and write this other one, 2x plus 6 over here, over, again, our x plus 3 times our x plus 3. Because, again, we may have something that we can factor out. So I'm going to go ahead and multiply the numerator and denominator over here by x plus 3, because that's what's going to give us the common denominator. So x times x is x squared. 3 times x is plus 3x. Then we got our plus 2x and our plus 6, right? So all of that is going to be over our x plus 3 times x plus 3. So we got a pair of like terms here. So we get x squared plus 5x plus 6. And that's all over our x plus 3 times x plus 3. So here again, we got to factor the numerator just to see if anything can factor out, okay? So let's go ahead and do that. So if we were to do that, what are the factors of 6 that add up to be 5? So that would be x plus 3 and x plus 2, right? And again, that's still over our x plus 3 times our x plus 3. Well, you should be able to see right now that we have the same factor over itself. So it's going to cross out and we're going to be left with this. So that is our answer right there. Now this time we only have one because x plus 3 is repeated. So we only have to say x plus 3 equals 0 to find where our x is undefined. So x cannot equal negative 3 because we're going to subtract 3 from both sides there. All right, so number 14, again, we're looking for the GCF, right? So what I'm going to do is factor all this stuff. So we've got our 2x squared minus 30, right? And it's going to be minus x plus 5, okay? But we can factor this right here, can't we? So this is going to be x plus 3 and x minus 3. So we had x plus 3 over here, so that means we're going to have to multiply both the numerator and the denominator by the x minus 3. Okay, so in the numerator, we got our 2x squared minus 30. Then we're going to have to do either FOIL or the box method, right? So x times x is x squared, so that's going to be minus x squared. And then we've got x times, actually, let's just leave this in parentheses for right now. So that's negative 3x plus 5x, so that would be plus 2x. And then 5 times negative 3, that would be negative 15. So we're going to end up changing the signs of everything in that set of parentheses. So this first term is going to be a negative, this is going to be a negative, and this is going to end up being a positive. Because we're going to have to combine our like terms there. So then we're still left with the x plus 3. All of it's going to be over that x plus 3, x minus 3, right? Because now we have a common denominator. So now we're looking at like terms, right? So we've got the negative 2x minus x squared. And that's going to give us, sorry, 2x squared minus x squared. So that's going to give us x squared. And then we've got our negative 2x. Only had one of those. But then we've also got the like terms of negative 30 plus 15, right? So that's going to give us minus 15. That's all still going to be over our x plus 3 and our x minus 3. So what we want to do here again is factor our numerator and see if there's anything in there that can cancel out, okay? So that's going to be equal to, if I can get my pen to work, there we go. What are the factors of negative 15 that add up to be negative 2? So wouldn't that be x minus 5, x plus 3? So I'm going to actually write these over each other that are like terms. So I'm going to do my x minus 3 here and my x plus 3 here, because notice again these are going to cancel each other out, right? So this is going to be my answer right there. But again, we got to set both of these numerator factors of the numerator equal to 0. So x plus 3 equals 0, so x cannot equal negative 3, and x minus 3 equals 0, so x cannot equal positive 3. All right, let's see if you guys can do 15. And then come back to me when you're done. So here again, we've got our 2x squared plus 64 over x plus 8, x minus 8, minus x minus 4 over, we had an x plus 8, so we're going to have to multiply that by an x minus 8 over an x minus 8. So we're going to get 2x squared plus 64. X times x is x squared. So again, I'm going to put my minus there and deal with that in a minute. So we got x squared, and then we got a minus 8x minus 4x. So that's minus 12x. And then plus 32. So once again, all of that is over our x plus 8. X minus 8. So let's see if we have any like terms here. So we do again here. Oh, let's actually deal with this negative out front first. So that's going to be minus, that's going to be plus, that's going to change to minus, okay? So this time we've got 2x squared minus x squared, so that's going to give us an x squared. And then we've got plus 12x, because again we only had a 1x to the first. And then we have this 64 minus 32, so that would be plus 32. And that's all over x plus 8, x minus 8. So once again, we need to see if we can factor this numerator. So what are the factors of 32 that add up to be 12? So that would be x plus 8 and x plus 4, right? So we have that over an x plus 8 over an x minus 8. So once again, hopefully you see this. Those two cancel each other out. So this is our answer right there. But we still need to set those 8s. So x plus 8 equals 0. So x cannot equal negative 8. Whoops, that thing didn't want to move, did it? Sorry about that, y'all. Let's see if I can get it to move now. And then we're going to set our other one equal to 0 as well. So we're going to do x minus 8 equals 0, so x can also not equal 8. All right, so we had a few extension problems, and these are our harder problems. But in this case, really, because this is over 1, right? So all we have to do is multiply everything that was in the denominator of the other one times the numerator. So we're going to do x squared plus 3x minus 40 times 4, right? All of that would be over the x squared plus 3x minus 40. And then we're going to subtract from it the 3 over x squared plus 3x minus 40. Okay, so that's going to give us 4x squared plus 12x minus 120 minus 160. My bad. Minus 3. All over x squared plus 3x minus 40. Okay, so that's going to be 4x squared plus 12x minus 163 over x squared plus 3x minus 40. So here again, I would factor this just to make sure, and we have to do that in the denominator anyway just to see where our undefined values are. So this denominator right here is, if we factor it, it's going to be x plus 8, x minus 5, right? So we're going to set each of those equal to 0. And I tried to see if there was any factors of 4x squared times negative 163. I couldn't reduce that at all, y'all. So this is all we're left with is this undefined value. So x cannot equal negative 8, and x cannot equal 5, okay? So this is one of those lovely ones, right? So, all right, so let's see if you guys can do the next two. So this problem right here looks to me like it can be reduced before we even begin. So because 8 over 8 times n plus 8, won't those 8s cancel out, y'all? And we're left with 1 here. And that's going to make this problem a little easier. So it's going to be 1 over n plus 8 minus 8 over n plus 2. So all we have to do now is multiply by the opposite denominators, right? So for this one, we're going to multiply by n plus 2 over n plus 2. And this one, we're going to multiply by n plus 8 over n plus 8. So this is going to be n plus 2 minus 8n. And we could just multiply that by the negative 8. So that would be minus 64. Then we wouldn't have to worry about the parentheses, right? So I'm going to take those away because I don't really need them because I multiply both by the negative 8. So that's all going to be over n plus 2 times n plus 8. So we've got the like terms right here with the n and the 8n. So that's going to be minus 7n. And then we've got minus 64 and 2. So that's going to be minus 62. And all of that, if we multiply, then nothing can be factored out of that. So if we go ahead and multiply this out, this would be n squared plus 10n plus 16. And then again, we got to set these factors equal to 0. So n cannot equal negative 2, and n cannot equal negative 8. All right, so let's do this last one. So here again, we would multiply the numerator, because this is 3 over 1, by x squared. So this is going to be 5 over x squared plus x minus 12 plus 3 times x squared plus x minus 12 over, again, the x squared plus x minus 12. So we're going to get 5 plus 3x squared plus 3x minus 36 all over. And let's go ahead and factor this x squared plus x minus 12 now. So that's going to give us x and x. And then what are the factors of negative 12 that add up to be positive 1? That would be plus 4 and minus 3, right? So now we're going to combine our like terms, which in this case we only have 1. So this is going to give us 3x squared plus 3x minus 31 all over. And again, if we were to multiply that back out, and the reason I did that, I factored is because we got to set those equal to 0 anyway. We're going to get x squared plus x minus 12 again here. And I, again, did not find any factors of negative 93 that add up to be 3. So this was our answer. And then we got to do our x plus 4 equals 0. So x cannot equal negative 4. And our x minus 3 equals 0. So x cannot equal 3.